Hi everyone. In this lecture, we will see syntax analysis and CFG in NLP. So, this is the third lecture. You can see the previous lectures in the description. So, before going into what is syntax tree, first you should know what is grammar is. A grammar is defined as the rules for forming well structured sentences. Grammar also plays an essential role in describing the syntactic structure of well formed programs, like denoting the syntactical rules used in conversation in natural languages. So, when I say grammar, immediately you may think about the formal languages in compiler design and theory of automata. You might have understood what a grammar is, okay, and it is applicable in the fields of computer science and mainly in programming languages and data structures. So in C language we use precise grammar rules to state how the functions are made and how the lists and statements help these grammatical preciseness, okay. So mathematically a grammar can be written as a four tuple N, T, S, P, where N or V it is called as a set of non-terminal symbols or variables. T or the summation symbol, which is set of terminal symbols. S is a start symbol, where S belongs to N, and P are the production rules for terminals as well as the non-terminals. So these set of words like terminal symbols, non-terminals, production rules, start symbol, all this will be familiar if you have just gone through the subject called compiler design or a theory of finite automata. If you have seen that, you might have known the basics of that. So how we are going to apply these grammatical concepts in NLP, that is what we are going to see now. So what is a syntax tree? It is maybe called as a parse tree. So syntax tree is a tree shaped diagram that shows how a sentence is structurally organized according to the grammar rules. So it reveals which words can be grouped together, which phrases form a larger phrases, and how the whole sentence is built hierarchically. So that is a syntax tree. So if you say how a sentence is structurally organized according to the rules specified, then it is a syntax tree. So language is not flat. So if you take the sentence, the boy ate a cake, is a list of words. Instead, we mentally group them as the boy can be a noun phrase, ate a cake can be a verb phrase. This is the invisible grouping, is what a syntax tree makes visible. Okay. So you think about the grammatical which we have in the previous lecture. I have told about the feature extraction techniques and all that. In that POS tagging we have seen. So if you gone through that, you can see that how noun, adjective, verb, and all is defined. So in a sentence, usually a sentence can be divided into noun phrase and a verb phrase. So this is actually, we won't think it like that when we talk a sentence or when we write a sentence. So it is actually divided as a noun phrase or a verb phrase. So this is the part of a syntax tree. So you please listen to this carefully. A typical tree has a root node. Usually we take root node as S, which is a start symbol, and internal nodes, which are phrases and constituents. Example, NP we define as a noun phrase, VP as a verb phrase, PP as a prepositional phrase, DET as a determiner, N noun, V verb. So these are all non-terminals. Leaf nodes will be the actual sentence words like the boy ate a cake. These are terminals. Okay. So if you see the simple example, the boy ate a cake, how the grammatical grouping will be is, so sentence is made up of noun phrase plus verb phrase, as I told you in the previous thing. So any sentence is divided into noun phrase and verb phrase. So yes is a sentence or a start symbol, whatever you say. It's a sentence in NLP, start symbol in compiler design or theory of automata. So S is a sentence which consisted of noun phrase and a verb phrase. So NP plus VP. And then NP can be determiner plus noun. Uh, Determiner is nothing but the that particular words. And a noun, a boy, girl, whatever. Verb phrase can be verb plus a noun phrase. Noun phrase can be same thing, determiner plus n, it's repeated there. So this is how we will write the grammatical grouping. Once you do the grammatical grouping, then you have to draw the tree. See here, the grammatical grouping is done. Now we will draw the grouping. So the boy ate a cake. So S is the start symbol or the sentence which is divided into NP and VP. NP is divided into determinants and noun. Verb phrase is divided into verb and noun phrase based on the rules which is given at the side, grammatical grouping. So determiner is nothing but the noun is boy, verb is ate. Again, noun phrase is divided into determiner and noun. So a and n is noun is a cake. So you can see that leaf nodes are terminals. So the boy ate a cake, the sentence has come. And based on the grammatical grouping, you are able to draw the syntax tree. Okay, this is how you draw the syntax tree. So first thing is yes, sentence is divided into noun phrase and verb phrase. So based on how your sentence goes on, you can make the grammatical grouping. So another example. So the girl saw a dog. So first you identify the noun phrase and verb phrase, do the grammatical grouping and draw the tree. So first you split that as sentence into two major parts, NP and verb VP, that is noun phrase and verb phrase. The girl is the noun phrase, saw a dog is a verb phrase. Now you do the grammatical grouping, NP plus VP. So NP is, determiner plus noun. PP is verb plus noun phrase. So when you draw the tree, yes, sentence divided into NP and verb phrase, and then NP is nothing but determiner and noun. So the girl will come there. Verb phrase is again verb and noun phrase. Noun phrase again it's divided into determiner and noun. So verb is saw, determiner is a, and n is dog. So like this, you can split it, and this is another sentence. The boy put the bag on the table. You split it, divide the sentence, and then you divide it as which is word category. If you want to make it more simpler, each word what category it is, you can write it down. Thus, determiner, boy is noun, put is verb. If you can write it, then easily you can draw the syntax tree, and you can also write the grammatical grouping. So once you write the grammatical grouping, then you can maybe this particular parse tree is sorry, syntax tree is not so proper, but you can easily divide. So how many times we can divide? Because verb phrase here we have another grouping, because on, the word on is there. Okay, so on can be preposition. So verb phrase can be verb, noun phrase, and also preposition phrase. So that you have to write it in the grammatical grouping. And then preposition phrase is again a preposition and the noun phrase, so that your sentence will be easily covered. So sentence is noun phrase and verb phrase. Noun phrase is again divided into determiner and noun. Verb phrase is verb phrase and NP and PP. So put will come as a verb. NP again you can divide it as determiner and noun. So the bag will come. Then PP can be either P and NP. So P can be preposition can be a on, and then again determiner and now the table can come. So this leaf nodes are the terminals. The boy put the bag on the table. So you can practice. Some of the sentences are given there, like a man walked through the tunnel. Teacher believed that the student passed. You can just practice and put the answer in the comment. Next, we move on to context-free grammars. So, what is a context-free grammar? A context-free grammar is CFG, is a notation that describing language as a superset of regular grammar, which you can see from the following diagram. So, regular grammar and context-free grammar is a superset of regular grammar. What CFG consists of? CFG consists of finite set of grammar rules and has four components, like how we have defined a syntax tree. set of non-terminals, set of terminals, set of productions, set of start symbol, which is yes, the sentence which we say. Set of non-terminals is represented by V. The non-terminals are variables that denote the set of strings. Set of terminals are also known as tokens, represented by summation symbol. Strings are formed with the help of these basic symbols or terminals. Set of productions means P, which we represent as non-terminals. You will put an arrow and then terminals. So left side of the production is called the non-terminal and the right side of the production is called the terminals. So start symbol, the production begins with the start symbol. It is represented by the symbol S, and non-terminal symbols are always assigned as the start symbol. Okay. So these are all the grammatical rules. So you will have the non-terminals, terminals, set of productions and start symbol. So you just go to this components. Terminals only appear as leaves of the parse tree or syntax tree. Right hand side of the production, uh, right, which is the right hand side of the production. Words of the language like cat, dog, is the, duck, bark, all these can be terminals. Non-terminals do not appear as leaves, appear on the left or right side of the productions. It is NP or VP or sentence, etc. Productions are the rules. One of the with one non-terminal on LHS and any number of terminals and non-terminals on RHS. So this is how you write. Already we have seen the grammatical grouping before. Similarly, a sentence is comprised of NP and VP, and VP is VP, NP, preposition phase, or V, NP, however you write. Nominal can be a noun or a nominal noun. Noun can be a dog, cat, or a rat, whatever determiner is the. So now we will see the example of context-free grammar. So G is equal to VTSP. V is nothing but variables. T the terminals. S is a start symbol and P is the production. This is how the grammar is defined. V is nothing but your S, NP, VP, all the non-terminals. T is all the terminals, A, eat, cake, child, folk, the, with any words. S is the start symbol. So you will write the productions based on that. So S production rule of S is NP-VP. NP can be either determiner or noun, or NP can be a NP preposition. So based on the previous grammatical grouping, you can write the same similar way. PP is a preposition and noun phrase. VP is verb NP. So determiner, it can be either a or the. Noun can be cake, child, or folk. Preposition with, and verb is ate. So here, how will you derive? You can see in context-free grammars, we won't draw a syntax tree. We will derive it. Okay. How we will derive it is shown here. So first is sentence is NP, VP. NP can be divided into determiner, noun, and VP is there like that. Determiner is the, noun and VP is there. Next sentence you can see it is one by one. If you check, the is first determiner is assigned, then noun VP is there like that. Then noun is changed to child, the child VP. VP again is split into verb and NP. So the child ate, verb is ate. NP. NP is again is a determiner and noun. So child ate, determiner is a noun, and a noun is nothing but a cake. The child ate a cake. From this derivation, we can understand that the sentence child ate a cake is a valid and accepted sentence by a grammar G. Okay, so if you derive like this, then it becomes a context-free grammar. If you draw a tree, then it becomes a syntax tree. So almost in NLP, the grammatical grouping is almost similar. Okay, so we can understand that how this grammatical grouping has done and how your sentences are. Okay, next we will see where we can apply this context-free grammar. So context-free grammar can be applied in grammar checkers, question answering, information extraction, machine translation, and dialogue management. So these are the various applications where you can use context-free grammar. So we will see one more example. The boy saw a dog in the park. So you know that grammar is VTSP. V is variables. It can be either S, NP, VP, PP, determinant, noun or verb or preposition. And T is the sentence, whatever is given. Based on that, you split it as tokens as the, boy, dog, park, in, saw. Then you write the grammatical grouping. Once you write the grammatical grouping, then you can derive it. So how will you derive it is given there. So yeah, sentence is NP-VP. NP is again you have a grammatical as NP as determiner noun or NP-PP. So if uh, whichever is fitting for the particular sentence, we will apply that. So determiner and noun and then VP. Determiner is the, noun VP. Noun can be boy. VP can be verb, NP and preposition. The boy saw, verb is a saw. NP and preposition can be, NP can be divided into determiner and noun. So the boy saw a, noun can be a dog. So a boy saw a dog. Then preposition can be preposition NP. That is PP is preposition phrase. So preposition phrase is preposition NP. So in is a preposition and again NP can be divided into determiner and noun. The will come there and noun can be park. So this is how you derive the context-free grammar derivation for a particular sentence. You can practice this also. One more example is given. The girl placed the book on the table. So there is a grammatical grouping. So how will you derive? So S is NPVP. So you know the sentence now based on the noun phrase and verb phrase, based on the sentence how it is aligned. So where the preposition can come, now on is a preposition, then automatically we use the preposition phrase. If preposition is not there, we will define it by noun phrase and verb phrase itself. So based on this, you can see the derivation. So this is just a practice for you how you can do it. Similarly, you can do the practice for this sentence. A student read the article with notes. You can try it out. Now, what I will do is I will show the CFG in Python. Okay. How will you implement in Python? So, you first import NLTK. From NLTK, you import CFG. So because in NLTK there is a package CFG and you have an NLTK parse and you can import a chart parser because if chart parser is there you can generate a parse tree. Okay. So grammar CFG from string I am giving the grammar and I am giving the sentence also the cat or mouse chased, that is the sentence. Simple example, create a parser for the grammar and then sentence is the cat chased the mouse. You split it, what it will do, it will split into each and every token, the separate, cat separate, chased the mouse. And then for displaying the tree, for tree in parse of sentence, the particular sentence which is splitted, then print the tree and tree dot pretty print will give you the formatting printed of a tree. So you can see that sentence is divided into noun phrase and verb phrase. Noun phrase is again divided into determiner and noun. Verb phrase is verb and noun phrase. And noun phrase is again determiner and noun. And then you know that leaf nodes are the terminal. Determiner the, n cat, we chased, the, and the mouse is the noun phrase. So this is how you implement the parse tree in the yeah, Python. Okay, so you will import NLTK and CFG. You give the grammar string and then you parse it. And the chart parser is used to draw the chart and then you print the things in the as a tree format. So this is how it is printed. Hope this lecture will be useful for you. Thank you.